For decades, we've been listening to the sounds of space, from static to radio waves to even songs performed by musicians. But what if there was a place so far away that the sound never reached us? Welcome to my channel. And today we're answering the extraordinary question, how far away can you hear sound? The answer might surprise you because it turns out sound travels much farther than you might think. However, there are limitations. Space is just too big. First, let's explore how sound works here on Earth. Sound is produced by vibrations. When a speaker vibrates, it disturbs the air molecules immediately outside it, which collide with ones next to them, which collide with ones next to them, and so on. This domino effect creates a pressure wave that travels like dominoes passing on vibrations that our ears interpret as sound. So for sound to exist, you need three: an energy source, a medium through which the energy can travel, and a receiver to pick up those vibrations. The speed of sound depends on the medium through which it passes. It travels fastest in solids due to the closely packed particles that easily pass on vibrations. It's slower in liquids, since the particles aren't as close together, and slowest in gases where the particles are widely spaced, requiring more energy to get them to vibrate. At room temperature, sound waves travel at about 343 meters per second, or 1,234 miles per hour in air. That means that if you were standing next to someone who was clapping their hands 100 times a minute, you would hear the sound of their clapping all the way out to a distance of 18 kilometers. However, as the sound waves spread out, their energy disperses, meaning that the volume decreases the farther away you are from the source. You may have heard of the inverse square law in physics, but essentially the intensity of something spreading out over an area is inversely proportional to the square of the distance from the source. So if you double the distance from the source, the intensity of the sound drops by 4 times. If you triple the distance, the intensity drops by 9 times, and so on. At some point, the sound waves become too weak to be detected by your ear, which is why you can't hear sounds that are happening billions of kilometers away. In fact, this is how astronomers detect sounds in space. They listen to the faint signals sent out by celestial objects like stars, black holes, and galaxies. Even though these sounds are incredibly faint by the time they reach us, they still give scientists valuable insights into the nature of these distant objects. For example, the study of gravitational waves has revealed a lot about black holes and neutron stars. But now let's shift our focus to outer space. Sound waves require a medium to travel through, and space is mostly a vacuum, meaning that sound cannot travel very far. NASA's Voyager 1 spacecraft, launched in 1977, has been exploring interstellar space for over 45 years and is now more than 24 billion kilometers from Earth. At its current speed of 17 kilometers per second, it will take Voyager 1 almost 50,000 years to reach the nearest star system, Alpha Centauri. And during that time, the spacecraft won't be able to make any noise because there's no air for sound to travel through. In other words, if you tried to shout on Voyager 1, your voice wouldn't be able to make it back to Earth. In fact, even if you were standing next to Voyager 1, you wouldn't be able to hear anything because space is silent. If you want to communicate with a spaceship like Voyager 1, you have to send a signal using radio waves instead of sound waves. Radio waves are part of the electromagnetic spectrum and can travel through the vacuum of space at the speed of light. Now let's explore a hypothetical situation. Let's imagine you're standing next to a massive explosion in space, something like the collapse of a star. This explosion would generate an incredible amount of energy, including sound waves that would radiate outward at the speed of sound in whatever medium they happen to be in. So how far away could you actually hear this explosion? If you're standing next to the explosion, you would be utterly obliterated before sound had a chance to reach your eardrums. So let's imagine you're a little farther away. To find the answer, we need to know the strength of the explosion, which is measured in terms of energy released. We also need to know the medium through which the sound is traveling, such as the density of gas in space. But for the sake of simplicity, let's assume that the explosion releases 10 to the 31st power ergs of energy, and that it occurs in a region of space with a medium density of hydrogen. When converted to sound waves, this explosion would generate a pressure wave that would travel through space at about 17 kilometers per second, which is the speed of sound in hydrogen gas. After 1 second, this sound wave would be 17 kilometers from the original explosion. After 2 seconds, it would be 34 kilometers away, and after 3 seconds, 51 kilometers away. Since sound waves spread out over time, the wavefront would start overlapping. The total distance covered by the sound waves would be roughly 51 kilometers. This means that if you were standing on a planet that was 51 kilometers away from the explosion, you would just barely be able to hear the sound. Of course, in reality, this is just a rough estimate. The actual distance would depend on many factors, including the exact strength of the explosion and the density of the gas in space. But it gives us a good idea of how far sound can travel in space under certain conditions. It's worth noting that space is not completely silent. In some places, there's enough gas for sound to travel. And in other places, there are charged particles that emit electromagnetic radiation, which can also be interpreted as sound. So while we may not be able to hear music playing on another planet, we can still listen to the sounds of space in our own unique way. Space is filled with all kinds of noises, from the hiss of solar winds to the crackle of auroras. And while these sounds may not be music to our ears, they tell us a lot about the workings of our universe. For example, the solar wind, which is a stream of charged particles flowing from the sun, creates a constant hum in space. This sound is too low for humans to hear, but satellites have picked it up and transmitted it to Earth, where it can be analyzed by scientists. Similarly, auroras, which are beautiful displays of light in the sky, also make noise. These sounds, which are created by the interaction between the solar wind and the Earth's magnetic field, can be heard by those who are lucky enough to be in the right place at the right time. While these sounds may seem random and chaotic, they actually tell us a lot about the workings of our solar system and the Earth's atmosphere. By studying them, scientists can learn more about everything from the strength of the solar wind to the composition of the Earth's upper atmosphere. So even though we may not be able to hear birds tweeting or dogs barking in space, there's still plenty of sound to be found if we know where to look. By understanding how sound travels through different mediums and using technology to listen to the faintest of signals, we've been able to unlock the secrets of the universe. From the Big Bang to the most distant galaxies, sound has been there every step of the way, providing us with valuable insights into the workings of our universe. So the next time you hear a strange noise in the night, remember that it might be coming from billions of kilometers away, carrying with it the secrets of the cosmos. And speaking of strange noises, have you ever heard the unsettling noise coming from the depths of space that's been driving people crazy? Well, you're not alone. Join me in this video as we explore the mystery of the unsettling noise coming from the depths of space. Who knows, you might just learn something new about the universe while scratching that curiosity itch. Click the link above to watch now. Thanks for watching. And if you'd like to learn more about our universe, don't forget to subscribe for more updates.